Hi guys, I hope you are all doing well. Let's see today's question. So today's question is from the topic of integration. And in this question, we have been told that we need to find the integral of log x minus 1 upon 1 plus log x the whole square dx. Okay, so we need to find the integral of this. We have been given 4 options. Let's try to find the answer and see which option matches the best for this question which is given to us. So if I try to solve this further, I can get this as, first of all, I can see here is best thing I can do is I can try to expand the numerator, because I can write this entire thing as log x minus 1 the whole square. So it is nothing but a minus b the whole square, right? And I further have here 1 plus log x square. So now if I use this idea here that a minus b the whole square, I get this as a square minus 2ab plus b square. Right? So if I try to expand this idea, I can write this entire thing as log square x minus 2 log x plus 1 upon 1 plus log x square the whole square dx. Now, further, if I try to simplify this, I get this as 1 plus log x square. So log square x, I can write this as log x square because it is nothing but actually log x the whole square, right? Because it is a square. So log x square and minus 2 log x. And now if I try to separate the denominator, there's 1 plus log x square squared, and here also I have 1 plus log x square again squared. So now what I can do here is I can directly cancel one of these terms from the first part. So I will be left with integral of 1 upon 1 plus log x square minus, here I am left with 2 log x upon 1 plus log x square the whole square. And this is further given to us as dx. So now what I can think of here is I need to substitute x as something, so it integral actually basically simplifies, right? So I can write this as, let's say, put log x as t. So if I put log x t, x becomes e raised to t, and here if I derivative it becomes e raised to x is dx is e raised to t dt. So now if I further write this, I get this entire expression is equal to 1 upon 1 plus t square minus 2t upon 1 plus t squared square, right? And dx, I can write this as e raised to t. So now I can think of one idea which we already have. So first of all, let me write it in that fashion only. So e raised to t 1 upon 1 plus t square minus 2t 1 upon 1 plus t squared whole square. So dt. Now if I think of, I can write this entire expression as e raised to x f of x plus f dash of x is nothing but e raised to x into f of x plus c. So I have this idea valid for me where I have e raised to x. So I have already here e raised to t. Now just let's find out, if I put this as f of x, do I get this same thing as the derivative of that? So let's try to find that out. So first of all, if I put that f of, instead of x, here we have f of t. So if I put f of t is nothing but 1 upon 1 plus t square, right? So if I take the derivative of that, f dash of t, it would become 1 plus derivative of 1 plus t square the whole raised to minus 1, right? It becomes, so x raised to minus 1, if you know it is, or x raised to anything, x raised to n's derivative is n into x raised to n minus 1. So if I apply that idea, I get here as minus 1 raised to, so minus 1 into 1 plus t square raised to minus 2 into, further I will derivate 1 plus t square, because I'm thinking of 1 plus t square as x, right? So further I get this is minus 1 upon 1 plus t square square, and derivative of 1 plus t square is, derivative of 1 is 0 and derivative of t square is 2t. So you get this as minus 2t upon 1 plus t square the whole square. So that's the whole idea I'm getting for the derivative of 1 plus t square. So if I put f of t as this, I am getting this entire thing as dash. So now I can write this as e raised to t into f of t plus f dash of t. And when I have the integral of this entire expression, I get the solution as e raised to x into f of x plus c. So in this case also, if I write this, the solution for the question which is given to us. Now we had this e raised to t 1 upon 1 plus t square, plus we had minus t upon 1 plus t square. This is nothing but e raised to t into f of t plus c. So now if I again resubstitute, because we need our answers in terms of x, right? We do not need it in terms of t. So we already know that we substitute here t as log x, and when we resubstitute t as log x, e raised to t I can resubstitute as x. So now my solution or the answer for the question which is asked to us becomes e raised to t. I can write this as directly x. Here I can write this as 1 plus log x the whole square plus. So we get the answer for the question, that becomes x upon 1 plus log x square plus c. And if you see, the option that matches here in the question is option A. So A is the correct answer for the question which is given to us, right? I hope you have understood how to solve this type of questions of integration. So first thing we did is we just expanded a minus b the whole square. Then we separated the denominators, one term gets cancelled, and then I substituted log x as t. Once I substituted log x as t, my entire question turned out to frame as e raised to x into f of x plus f dash of x. That is nothing but e raised to x into f of x plus. That gave me the answer as e raised to t upon 1 plus t square plus c. Again, resubstituting t as log x, I get the answer for the question. That is option B. I hope you have understood how to solve this type of questions of integrals. I'll meet you again tomorrow with the next question. Till then, you can like, share, and subscribe to my channel. Also, share these videos with your friends who are also involved in the preparation of JEE. Thank you.